For Bronsted-Lowry acids and bases, you're going to look at some equations that actually don't need to be balanced, but it's just showing where is your hydrogen traveling around. The first thing that you need to do is you need to pair these up. When you pair them up, the difference is going to be a hydrogen ion, because what's actually happening here is your hydrogen ion is going to leave one of the compounds and it's going to travel to the other one. When we follow the hydrogen and try to figure out where it is, we're going to know that if you have an acid, it's going to lose a hydrogen ion. If you have a base, it's going to gain that hydrogen ion. So when you look at these, you have your before picture over here and your after picture. When you pair them up, you're going to look to see, okay, which two look the most similar, the only difference being a hydrogen ion. So this one and this one look similar before versus after. The only difference is that hydrogen ion, H+, is missing. These two are similar as well. Again, the only difference is that difference of your hydrogen ion. So what we did here was we actually figured out the conjugate acid-base pairs. Your acids and bases are reactants. Your conjugates are your products. So reactants are acids and bases, your conjugate acid and your conjugate base are your products. So if we want to figure out what is your acid, we know that the acid loses a hydrogen. So on this one we have a hydrogen before, and then the after picture the hydrogen goes away. So this one is your acid. Your base is going to gain the hydrogen. So here we have 2 hydrogens, here we have 3, so that makes your base. When we look at the products, we need to remember that acids make conjugate bases on the other side. Bases make conjugate acids. And that's because these things will actually switch back and forth. So if you have an acid making a conjugate base, when this goes backwards, the base is going to gain the hydrogen to make the acid the conjugate. So looking at these, they're the opposite. Acids make conjugate bases, bases make conjugate acids. So looking at your pair, first thing you want to do is just identify which pairs go together. The second thing that you want to do is you want to identify the acid and the base, which are your reactant side. Your conjugates are your products. Acids make conjugate bases, bases make conjugate acids. Now with your dissociation, we can actually figure out what is going on in your equation just by looking at your compounds here. So this says that it's an acid. Acids are going to lose a hydrogen ion. So you're losing hydrogen with a +1 charge off of your compound. When you lose that, basically that one hydrogen is going to go away. So you're left with no hydrogens. So ClO4, you lost a +1 charge, so that leaves you with a -1. Same thing happens with your bases. Bases are going to gain a hydrogen. So we're going to add a hydrogen onto your compound. You had a -1 charge, you're adding your plus, so that's just going to make HCN. So looking at these with your conjugates, you have to keep track of your positive charges and your negative charges, and you have to figure out, are you gaining or are you losing that positive? Along with this, if you want to write out the full dissociation, here we have an acid, H3PO4. When we lose a hydrogen, we had 3, now we only have 2. So HPO4, this did not have a charge. When we go through and lose that hydrogen with a +1, we end up with a negative charge. So to show the full dissociation on what's happening, H3PO4 is what we started with. You're losing a hydrogen to the base, so that's going away. What's left over in your solution is H2PO4 -1. To do one going backwards, if we have something like this one, the SO4 -2, that's just a sulfate. We wanted to know what was the original acid. So if this is a base, that means that it lost a hydrogen to go from here to here. So we're going to add on 1 hydrogen, SO4. That hydrogen has a +1 charge, so it's going to cancel out one of those. So it had a -1. So this loses a hydrogen, you end up with the SO4 as a conjugate base. So if we write out your dissociation, HSO4 negative 1 is going to break apart. That hydrogen is going to go to the base, and then you're left with SO4 negative 2.